Continuing with the concept of critical velocity. I hope you remember what is critical velocity. It's the velocity required for the satellite to be launched in a perfect circular path. In the earlier module, we understood the statement and we understood the formula for critical velocity. Okay, that was in terms of capital G. There is one more expression for critical velocity in terms of acceleration due to gravity, that is small g. Obviously, the satellite is at a height, so we call it as acceleration due to gravity at the height as gh. So, as the name suggests, critical velocity in terms of gh. Let's understand this expression for critical velocity in terms of gh. Let's consider a satellite which is revolving in a circular path at a height h from the surface of the earth, where capital R is the radius of the earth. Now, the weight of the satellite is equal to the gravitational force acting on it, right? Actually, the weight is nothing but the gravitational force. So, if I consider at one point the satellite is revolving in a circular path, the weight or the gravitational force will be acting towards the center, right? And that weight is nothing but equal to the centrifugal force, which is numerically in terms of magnitude same as the gravitational force. So I can say weight is equal to gravitational force. Now what is weight? Weight is nothing but mg. But here g at a height is not taken as simply g, it is taken as gh. So let gh be the acceleration due to gravity at the height h, right? And let m be the mass of that satellite. So in place of weight, I can write in place of weight as m into gh. So that is weight. Now gravitational force. You know, gravitational force is g m1 m2 upon r square. In this case, let's say the mass of earth is taken as capital M, mass of the satellite is taken as small m. The distance from the center of the earth to this satellite is nothing but capital R plus h. So the gravitational force formula becomes gmm upon r plus h the whole square. Perfect. Cancelling small m on both sides and rearranging, I get gm is equal to gh into r plus h the whole square, right? Remember this, this is going to be our connect. Now you remember in the earlier module we derived the critical velocity formula. The critical velocity formula was given as root of gm upon r plus h. I hope now you are very clear why I found out gm separately. What am I going to do? Yeah, you are absolutely right. I am going to, in place of this capital gm, I am going to substitute this gh into r plus h the whole square, so that I can get a formula for Vc in terms of gh, and that is nothing but an expression what we want, right? So substituting gm as gh into r plus h the whole square, I get Vc is equal to square root of gh into r plus h the whole square divided by r plus h. What is common in the numerator denominator? Yes, there is one r plus h common. So we cancel that r plus h, one r plus h term, and your final conclusion or expression is Vc is equal to square root of gh into r plus h, where r plus h is the radius of the orbit, which is measured from the center of the earth, and gh is the acceleration due to gravity at that height. Note, we can make a special condition also from here. Suppose if they ask you what is the critical velocity very close to the surface of the earth. So very close to the surface of the earth, h will be approximately 0, negligible. So then in that case, gh would be just simply g, and Vc can be written as root of g into r. Okay, that would be a special case, very close to the surface. But at a height, we always write it as Vc is equal to root of gh into r plus h.